I wanted to get just a couple more examples in here, so let's look at example 8. It says all edges of a cube are expanding at a rate of 6 centimeters per second. How fast is the volume changing when the edge is 10 centimeters? So what they're giving us is the edge, so let's look at given. They're giving us the side is 10 centimeters. They're also giving us the edges are changing at a rate of 6 centimeters per second. So that would be S prime equals 6. What do they want? They want the volume, the rate of change of the volume. So what's our equation here? Well, we're looking at the volume of a cube. And remember, a cube, a three-dimensional box is length times width times height. But a cube very specifically, length, width, and height are all the same. So the volume here is really S cubed. Length times width times height would be S times S times S. What do we do with our equation? We take the derivative with respect to t of both sides. When we do that, on the left-hand side, we would have v prime equals the derivative of s cubed would be 3s squared times s prime. Again, what do we know? Let's use our given information. We know that s is equal to 10, and we also know that s prime is equal to 6. So nice and easy on this problem. We have v prime equals 3 times s, which is 10, squared times s prime, which is 6. Plug that into your calculator if you need, and I'm getting a total of 1,800. Now remember, this is volume, so this is going to be whatever the length is cubed. Volume is cubed, so that's going to be centimeters cubed per the rate of time, which is second. So the volume is changing, increasing at a rate of 1,800 centimeters cubed per second, or cubic centimeters per second. Let's go to the last example. Example 9 here says the radius r of a sphere is increasing at a rate of 3 inches per minute. Find the rate of change of volume when r equals 9 inches. So what's given to us? We're given that r equals 9. I see that right above there, right? We're given us the radius is changing at a rate of 3. So that's r prime equals 3. What do they want? They want to find the rate of change of volume, so they want v prime. Let's think about the equation. So they want the volume of a sphere. So go back and look at the volume of a sphere, and let's see what we get. The equation for the volume of a sphere, if you remember, is 4/3 pi r cubed. What do? Take the derivative with respect to t of both sides of this. The derivative of v is v prime. Remember, 4/3 pi is a constant multiple, so that stays out in front. The derivative of r cubed would be 3r squared. Don't forget the chain rule, multiplying it times r prime. Look at the given information here. We know what r is. R is 9. We know what r prime is. R prime is 3. So what would we have? We would have v prime equals 4/3 pi times 3r, which would be 9 squared, times r prime, which is 3. I'm going to do a decimal approximation on this one. I don't need an exact answer. So in my calculator, I'm doing 4/3. I'm putting in a pi there, times 3 times 9 squared times 3. Hit enter, and I'm getting 972 pi. But that's not what I want. I want the decimal approximation, so I hit the double arrow button, and I'm getting about 3053 point, I don't know, let's just do one decimal. How about 0.6, okay? What is that in terms of? Well, this is volume, so it's going to be whatever your unit is cubed. In this case, it's inches cubed. And then it's per the time, which is measured in minutes. So I'll just go ahead and box that because it's right above the answer. So I'm getting 3053.6 cubic inches per minute would be the rate of change of the volume of the sphere at that exact moment in time. So again, in summary, when you're doing related rates problems, this is often one of the most difficult sections in Calc 1, and you probably saw that on the previous 2 pages. Related rates problems, I'm not going to test you on the most difficult related rates. You are going to get frustrated on your homework. You do need to work through some of the more difficult examples. Just remember, on the test, I'm not looking to kill you. What I'm looking at is, can you read a problem, from the problem determine what's given, what you want, can you come up with the equation, you differentiate both sides, you plug in the given information, and you get the answer. Now, when to plug in the given information, there might be one small piece, like there was with the boat and the dock problem, where you had to solve for one missing piece, but it would be nothing like the previous, I think it was 3 problems ago, where we had to solve for virtually every single part that was in that equation. Not one of them was given to us. So I'm not looking at doing that hard of a problem for you. So I hope that puts you a little more at ease. Struggle through this section, get through this section, make sure you look at Calc Chat for the solutions to each and every one of the problems in the extra practice. Good luck on your homework and your quiz.